This is afternoon. Good afternoon. These are going over the notes in case you were absent or late or whatever from 19D, covalent bond structures, part 1. First bit, in covalent bonds, electrons are... This should be shared. You hopefully know this, but this is review from the last few days. It was in that puzzle and the stuff we did yesterday. Next, covalent bonds are usually between two nonmetals. This was from Tuesday's assignment 17D. If that is completely foreign to you, go do that assignment. Next, goal number 1, find the number of valence electrons in a covalent compound. So our steps to determine the number of valence electrons in a covalent compound is 1, determine how many valence electrons are in each atom by looking at the periodic table, and 2, adding them all up. So the first example here is OF2. Up top, we have a list of all covalent compounds. There's 4 covalent compounds here. Next row is the number of valence electrons in each atom, and then the third row is the total valence electrons. So the first one we have is OF2. I have an O here because there is just one O. So the number that follows the O is how many of that atom, that element there is. So we have O, and then there's just one of them. That's why there's only one listed. And then we need to go to the periodic table, find the column that O is in. It's located over here. Count to that column to figure out how many valence electrons are in O. 1, 2. Skip all the little low ones, these pink ones. So then 3, 4, 5, 6. Oxygen has 6 valence electrons. We do the same thing for F. So F is right next to O. It's one farther. O was 6, so F is going to be 7. There's 2 Fs because it's F and then a little 2. That's why there's 2 there. So we have 6 plus 7 plus 7. My total valence electrons is 20. I will work through O3 as well. I'm just going to talk through it though. So we have O3. We need to look at the periodic table and find O. So it is located here. Again, that is in the 6th column. So there are 6 valence electrons in one O, but we have 3 of them. So the total valence electrons for O3 would be 18. And then you can do PCl3 and NH4 on your own. Just to start it off, for PCl3, there's 1 P because there's no number that follows that P, so it's just 1. And then there's going to be 3 Cls. And I'm moving on. So goal number 2 is determine the number of valence electrons in a Lewis drawing of a covalent compound. We're also kind of determining if these drawings are accurate or not. So I'm going to work through example 1. It is color coordinated, so like question 1 is in red. So if you need to know how to do that, go look at the red. So on and so forth. Hopefully that makes sense. So the first, on example 1, what we have here, actually, these images to the right, these are covalent compounds, okay? And these are drawings. You're going to learn how to draw these eventually. But for today, we're just deciding, are they accurate? We're interpreting them, kind of figuring out what is this telling us. So the first question relating to this one is how many valence electrons can 2 oxygen atoms have? And how you do that is it's what we did up top. So it's repeating what we just did with this red and the total valence electrons. So I know there are 2 oxygen atoms. I know there's 2 because there's 1 O and 1 O. That's 2 O's, 2 oxygen atoms. So I go to the periodic table. I find O. It's in the 6th column still. 1, 2, 3, 4, yeah, 6th column. So there are 12 valence electrons because in 1 O there's 6, and in the second O there's 6, which gives me 12 in total. Next is how many valence electrons are drawn in this picture. So this is the picture. I need to figure out how many valence electrons are actually drawn. So I need to read this green bit. It says how to count the electrons drawn. Each dot is 1 valence electron. Okay. And then a single bond, which is 1 line, is a pair of electrons, meaning 2 valence electrons. Or a double bond is 2 lines. This is 2 pairs of electrons. It's 4 electrons. A triple bond is 3 lines, 3 pairs of electrons. That's 6 total electrons. So in my case, I have 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons, 6 electrons, 7 electrons, 8 electrons, 8 valence electrons. And then I have a double bond. A double bond, notice, a double bond is 2 lines, is 4 electrons. So I had 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. because each line represents 2 more. So I have 12 that are drawn. Does each atom fulfill the octet rule? A full outer shell of electrons is the octet rule. Hydrogen and helium are starred up here. They're important. They only want 2 electrons. The rest, all the other elements, they want to have 8 in their to make their outer shell full. So, how do we check that? We look. Remember, electrons are shared in covalent bondings. Anywhere there is a bond, that is indicating that those electrons are shared. So, if you look at the oxygen on the left, there's 1, 2 touching it up top, 3, 4 electrons touching O on the bottom, and then the lines are touching O as well. So that's 5, 6 for the top line and 7, 8 for the bottom line. So the O on the left is happy. Octet is satisfied. Then we do the O on the right. Again, we are recounting. We are keeping this double bond, and it goes towards the O on the right as well because these electrons are shared. So we have 1, 2 on top, 3, 4 on the bottom, 5, 6, and then 7, 8 from the double bond. So yes. Does each atom fulfill the octet rule? Yes, they have 8. And remember, hydrogen, which does come up later, and helium only want 2 electrons, not 8. So is this drawing accurate? The answer is yes. This is why it's yes. The number of valence electrons that the compound has, so the answer to question number 1, is the same as the number of electrons that are drawn, question number 2. And each atom satisfies the octet rule, which is question number 3. So these two, 1 and 2, have to match, and question 3 has to be yes in order for the drawing to be accurate. So that is that one. I will talk through this one. I'm not going to type anything because sometimes people just skip to the end of the video for the answers. So for this one, how many valence electrons can 2 fluorine atoms have? We have 2 fluorine, so we need to find it on the periodic table. F is located here. I count the columns, 1, 2, skip the low ones, and then 3, 4, 5, 6, 7. So fluorine has 7 valence electrons. There's 2 of them though, so this would be 14. Yeah, 14 valence electrons. That's how many it can have. That's how many it should have. It should have 14. It should not have more. It should not have less. So next we need to count them. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots. Some people stop there. Don't stop there because we also have the bond in the middle. So that bond represents 2 more. So we had 12 and then the single bond in the middle. So that's 13, 14. So how many valence electrons are drawn? 14 are drawn. Does the atom fulfill the octet rule? You'll look at the atom on the left. 1, 2, 3, 4, 5, 6, 7, 8. Yes, that is happy. And then we shift it and look at the atom on the right. 1, 2, 3, 4, 5, 6, 7, 8. And again, you share the single bond. Those electrons go to both sides. Anything that it's touching, they go to. And you count them in that. So does it fulfill the octet rule? Yes. Is this drawing accurate? Yes, because my answers to 1 and 2 were the same. They were both 14, and it fulfills the octet rule. 3 and 4 are your homework. That's all.